Hey everybody, today we are going to take a look at our first little lesson here for introductory statistics. In this lesson we're just going to go over some basics, sort of a big picture look at what is statistics, and we'll get into a few definitions. This course is pretty heavy on definitions here at the beginning, so we'll get a bunch of those out of the way. So I encourage people to watch these and view these sort of as a lecture. If you like to take notes, that's fine. If you don't want to take notes, that's fine too. I'll also provide the PowerPoints for you to print out or save on your own computer. So those will be available for you to look back on if you want to look back on the material but don't also want to view the entire video. So to start looking at the field of statistics, we can start out with just sort of a simple example. So suppose, for example, that you've been hired by the college and your task is to estimate, well, what percentage CBC students are out there working at least part-time. So maybe you're going to get a stipend, or maybe this is just part of your regular job. This is your goal. Okay. Now, if this is your job, how do you go about actually estimating something like a percent of all CBC students? Could you even possibly talk to every CBC student even if you wanted to? Unfortunately, the answer is, well, we probably can't, right? It's almost impossible to talk to every single CBC student. Even if you send out an email to every CBC student, they don't all check their emails. And even if they did, that doesn't mean they're all going to respond to you. And even if they did, that doesn't mean that they tell you the truth. Or even if they did, by the time you collect all your data, well, then some students have left, some students have came, and now your population is totally different, okay? When thinking about this, do you think it's even possible to know exactly what percentage of students are working? And the answer to that is also probably we can't, right? Because our population of students is just constantly changing. People get jobs, people lose jobs. Sometimes people work more, sometimes people work less. It's going to be almost impossible to know exactly right now what the percentage of students working is. Okay, so we're left with this problem. We're trying to estimate a percentage, but we'll probably never actually be able to estimate it exactly. Okay, this is a good example of where the field of statistics comes in. The actual field of statistics is more of a process. It's a process of collecting, organizing, summarizing, and analyzing data to draw some conclusions, and hopefully we can do that with some measure of confidence. The way I tell people is sort of in layman's terms, essentially as statisticians what we do is we make educated guesses, and hopefully very educated guesses, so that the guesses we come up with are something kind of close to the truth. Okay, so alright, so we have this question in mind, like we want to figure out what percent of students work. Well, let's say that we say, all right, I'm going to go, I realize I can't get the percentage exactly, but I'm going to go try to make a really educated guess. Well, how do you go about estimating this? Okay, well, the first thing you're probably going to want to do is maybe you can't talk to all of the students at CBC, but maybe you could talk to some of them. So typically speaking, in statistics or as statisticians, once we know the question that we're trying to answer, the very first step we're going to do is we're going to go out and we're going to collect data. That means we're going to go out, we're going to talk to individuals, or we're going to observe individuals in our population, and we're going to collect information about them. All right, so I have a question I want to answer. I know that I need to go out and collect some data to try to answer that question. And so the question becomes, okay, well, how do I get that data? So when we're trying to learn about CBC students, for example, we've already decided, okay, it's pretty much impossible to observe the entire population of students. Okay, well, if we don't have access to the whole population, well, maybe what we could do instead is we could observe what we call a sample. And this is what we do as statisticians. Can't observe everyone? All right, maybe that's not the end of the world. Let's just observe a subset of that population, and maybe that subset, that sample, can give us enough information to make an educated guess. So a couple definitions here. The population That's that entire set of individuals that we're interested in. Unfortunately, as we've noted, that population's probably unobservable. Either it's too big, or it's too expensive, or it changes too often for us to be able to observe it. So instead what we do, we take a sample. The sample is a subset of individuals from that population, which you're going to actually observe. This is where you're going to collect your data. So since you can't look at everyone, what do? You just look as many as you possibly can, and then hopefully we'll be able to make an educated guess from that sample. All right, so we know we can't observe the population, so we go out and we take a sample. All right, so how do we use that data? So let's say you end up with a sample of 75 CBC students. And from those CBC students, maybe you take a quick survey of your students and you find that 67% of them are working at least part-time. All right, so this is good. We have hard, fast numbers. I took a sample, 75 students. That's quite a few students. 67% of them are working at least part-time. That's a nice numerical summary. Tells me something about the sample you observed. Now the question is, does that actually mean that 67% of all CBC students work at least part-time? And the answer is, well, pretty much no, right? Because remember, this is just a sample. We only observed 75 of the some 7,000 CBC students. So I know that even if 67% seems like a reasonable guess for the whole population, in reality, the truth for the whole population probably isn't exactly 67%, and we kind of realize that. The value we're trying to estimate, so our goal would be to know the percent of all the students that are working. We have a name for that. That's called the parameter. That's the parameter we're interested in. The value we actually observe, so like in this case, 67%, that's referred to as a sample statistic. So the field of statistics is sort of like this overall process of where we collect data and analyze it and make inference. But a statistics itself is a numerical measure of the sample. So I'll get you a few more definitions here. Excuse me, we distinguish parameters from statistics. A parameter is a numerical value which describes the population. So parameter, population, they both start with P. That's kind of convenient. That's the value we're interested in estimating, but of course, since the population is unobservable, typically we can't ever know the parameter with 100% certainty. Okay. So, what do? Well, we do have statistics. And statistics are numerical values which describe the sample. So, the statistic is a value that we would actually calculate from our sample and hopefully use it to estimate the parameter. So you've got parameters describing the population, P's, statistics that describe the sample, S's. And together, these all kind of fit into what I refer to as the big picture of statistics. So in the big picture of statistics, you have a population, which is typically unobservable. From that population, you'll take a sample. From that sample, you'll calculate statistics. And from those statistics, you're going to estimate parameters, because those parameters are the things that describe the population. Now, typically speaking, statistics, or the field of statistics, is split into two separate types of analysis. So looking at this big picture of statistics, if you're working over here where you've taken a sample and you've calculated some numbers about that sample, we refer to that as descriptive statistics, because you're describing the sample. If you take the step where you actually use those statistics to estimate parameters, so you're actually trying to make educated guesses about parameters, that's what we call the inferential step, or inferential statistics. Okay, so we've got some vocabulary words flying around here, so let's take a chance and let's practice and see if we understand. So in our example, we were trying to observe what percent of all CBC students worked at least part-time. We sampled 75 students, And we found out that of those 75 that we sampled, 67% worked. So, excuse me, let's call out a few of these terms that we've been using. So in this example, what would be the population, what would be the sample, what would be the parameter, and what would be the statistics? And we'll start here at the top. Okay, so remember, the population is the entire set of individuals that you're interested in. So in this case, the population would be all CBC students, everybody. The sample is the subset that you actually observe. So that would be the 75 students that we actually observed. The parameter describes the population. It's typically what we're actually interested in making inference about. So the parameter is the percentage of all CBC students who work at least part-time. Notice there's no numerical value associated with the parameter. I don't have a number to assign to it because I don't know what it is. I don't know what the truth is. That's what we're trying to estimate. So the parameter is usually a value. It's just a value that you'll never know for sure. What we do have, though, is we have a statistic. We have a number that describes the sample. That's the 67%. That's the percentage of our sample which worked at least part-time. Okay, so we kind of have an idea of what the big picture of statistics is. We looked at a small little example, and we have some terms to go along with that. Now, when you go out and you collect data, though, not every type of data is exactly the same. So I'm going to show you another example. So let's say that a teacher goes out and they collect data about their students. So they give them a little survey and they ask them to provide certain information. You'll have to excuse me, I've been a little sick over break, so I'm having some trouble over here coughing, so I apologize for that on the recording. But anyways, so they took a survey, and this is what they said. They said, okay, tell me what your gender is. Tell me what your commute time is. How much time do you spend driving to school? Tell me how much money you spent on groceries in the past week. Tell me what your marital status is, and they give them options. So you can either say never married, married, divorced, or maybe you're a widow or a widower. And they ask them, how many pets do you have? How many text messages a day do you send on average? And how much did you spend the last time you purchased a clothing item? Now, you can measure all 7 of these things about every single individual, but you'll notice that many of these variables are measured quite differently. Like, for example, your gender is going to be, you're going to record like a word, like male or female, whereas on your commute time, you're going to record a number, like minutes or something. Same with marital status, With marital status, you're going to pick an option, never married, married, divorced, widowed or widower. Whereas with pets, you're going to provide a number. And even within the numerical ones, right? So like, how many pets do you have? Well, most people are only going to claim 0 or 1 or 2 or 3 pets. But if you ask me how much you spend on groceries, you could say $112 or $112.05 or $112.07. So each of these variables are a different type of variable, and we classify them. It's important to classify what types of data you're working with, and they typically break down like this. Okay, so typically your data breaks down first into 2 categories. That is qualitative versus quantitative, and the key is in their name. So qualitative speaks to the quality of an individual. It classifies individuals into categories or groups. It's typically non-numerical. So it's not a numerical value. It just says you belong to this group. You have green eyes, therefore you belong to the green-eyed group. All right? Quantitative, on the other hand, it's numerical values. And those values have some natural ordering. So if you are, your age is a quantitative variable. So if you are 30 years old and someone else is 23 years old, you at 30 years old are older than the person who's 23 years old. There's a natural ordering to it. So it's numerical and there's an ordering. Okay, so that's the 2 basic splits, which is qualitative versus quantitative. All right. Well, within quantitative, though, we also notice a difference in our variables in the last slide. we break it down further into what's known as discrete versus continuous quantitative data. So a discrete random variable, these are variables that can only occur on fixed intervals. These are typically integer values. So these are things that you would only ever claim like 0 or 1 or 2 or 3 of. You would never claim like 2.5 of. Whereas continuous variables, these are numerical measures which can take on an infinite number of values. All right. So if we look back to our demographic survey, we can go through each type of variable and classify it. So gender. Gender is non-numerical, and it classifies you into a group. So that would mean it would be qualitative. Commute time. Commute time is a quantitative variable because it's numerical. I also think, if you think about commute time, you can record a commute time of, you could say I commute for 15 minutes, or I commute for 15.1 minutes, or I commute for 15.76 minutes, right? There's like an infinite number of decimals you could pick on a commute time. So we consider anything measuring time a quantitative continuous random variable. Similarly on money. So you spend a certain amount of money per week, but given dollars and cents, there's a whole lot of combinations there. In fact, you could even take money beyond the hundredths, beyond the cents. We just round it off for our everyday transactions. Anytime you're measuring money, we typically think of that as also a continuous random variable. So that's quantitative and continuous. If you look at marital status, however, this is non-numerical, just classifies you into groups. So that would be another qualitative random variable. If you look at how many pets people have, okay, well, when you talk to someone about how many pets you have, you're never going to claim like 2.376 pets. You're always going to claim none or 1 or 2 or 3 or more. So because it's numerical, it's quantitative, but because you would only ever pick like integer values, you would choose, that would be a quantitative discrete random variable. With text messages per day, you also can't send like partial text messages, so that would be another example of a discrete quantitative variable. And then the last one, how much did you spend on item of clothing? Well, again, that's measuring money, so that's something we think of as continuous. Excuse me. All right, so this is a pretty basic rundown. Okay, we got our big picture statistics. We kind of know what the general big picture of statistics is, and then within that, now we've talked a little bit about gathering data, what types of data are out there. In our next video, our next little lecture, we're going to talk about, okay, so I know I need to go out and get this data, and I know how data differs, but how do I actually get it? Like, how do I pick which students to sample? Do I just pick the first 75 I run into, or should we maybe put a little more thought into how we select people for our sample? So that's coming up next time. In the meantime, you can go ahead and start getting started on your Chapter 1 homework and bring questions into class, and look forward to seeing you during class.